Okay, in geometry, there was something called special right triangles. Used to be in the standards. If you were like in honors or something, it was definitely in the standards. If you were in CP, they removed it from the standards at some point. And the reason why is because people in the state thought, why do we need to teach special right triangles when you could just do trig and get the same answer? And the problem with that is, if you were going past trig, you were going into pre-calc, calc 1, calc 2, calc 3, you needed to know the special right triangles, because just doing basic trig would give you an answer of a decimal instead of the answer of, say, square root of 2 over 3. And your calculator cannot generate this in radical form. It can only spit it out as a decimal. So that was the problem. So what I'm about to show you may be new. If it's new, you need to know it. It's no big deal. If it's not new, then I hopefully refresh your memory on it. We're going to learn it today, practice it tomorrow, because with pre-calc, when we get to the unit circle is built off of special right triangles. So if you know the special right triangle relationships, then you understand a unit circle way better. Okay, there's two types. You have a 45, 45, 90, or you have a 30, 60, 90. You will notice that if you add these 3 degrees up, they all equal 180. 45, 45, 90, because two angles match, that dictates how many sides match. So what type of triangle is that? Starts with an I. Isosceles. So the two legs would be congruent in every 45, 45, 90 triangle. And that's because the two angles are congruent. Now in a 30, 60, 90 triangle, you don't have anything congruent. And we nicknamed 30, 60, 90. Let's see, this is the long side, so that would come from the larger angle. This is the short side, so it would come from the smaller angle, and of course you have the hypotenuse. So the way you label this is your hypotenuse, this is your short side, and this is your long side. The way you label a 45, 45, 90 is more of whether it's a leg or it's the hypotenuse. So the hypotenuse is over here, and then this is a leg, and this is a leg. And the reason we just call them that is because they're equal. There's no need for like short or long, because they're the same length. Okay, there's a relationship between all of the sides of those two special right triangles. The relationships are formulas. Okay, so we're going to open up our flip book, and right here on the left are the formulas. I do want to make one small adjustment, and if it drives you nuts, you're welcome to my whiteout. I personally don't like using an S. They're using S for a side. I like to use X. And the reason why is because when you get to the 30, 60, 90, S could be misconstrued as the short side, and it's not. So when you come over here, I'm going to change this to X. I'm going to make it, there we go, X, X, X root 2. This is X, X, X. All right, let's look at one at a time. We'll go with the 45, 45, 90. The relationship is, since these are congruent angles, and we said that these are congruent sides, if you know one of the legs, then you know the other leg, right? And then the hypotenuse is the leg times root 2. This is how you read it. It's going to be the leg times root 2. Okay? So look at number 1. Go to what you know. You know a leg. Well, if you know one leg of a 45, 45, then you know the other one. So you can come over here and say, all right, x must be, let me change this so it's thicker. All right. So x must be 7. And then y is, look at the formula, leg times root 2. So the leg was 7, so it's going to be 7 root 2. Now the reason that one was short and simple was because you knew one of the legs. Number 2, you also know one of the legs. It's just not a pretty number, but it's still the same concept. So I know a leg right here. So x must be root 5. The hypotenuse is the leg times root 2. So just write it, leg times root 2. And then now you got to know your properties of radicals. So root 5 times root 2 is root what? 10. You can multiply numbers under a radical. Any number times any number if they're under radicals. You cannot add or subtract numbers under radicals if they don't match. They have to match in order to do adding and subtracting. Multiplying, fair game. Number 3, you know both legs. You need the hypotenuse. So it's going to be leg times root 2. So it's going to be what? Root 6. Now, number 4 is an example of where you don't know the leg. Instead, you know the hypotenuse, which means you're working backwards. Okay? So the way you do this, first you recognize, okay, that's the hypotenuse. You go to your formula, and you say to yourself, what's the formula? It's leg times root 2. And you write it right here. Leg times root 2. So, leg times root 2 has to equal 12. Right? And then you just decide which one you're going to solve for. Does it matter which one I solve for? No. So I'm going to use x since that's what I'm used to seeing over there. So I'm going to set it up. The leg times root 2 has to equal 12. The leg I want to solve for first is x times root 2 equals 12. I need x by itself, so I'm going to divide by root 2. You probably know where this is going. This is why this is the long version. You have 12 over root 2. That is the answer. That is not the correct format. So if you're not comfortable with fixing the format, I would encourage you to type that in your calculator and see the decimal and leave it. So then after you fix the format, you can type it in the calculator and the 2 decimals should do what? They should match. So that's a way to check yourself as you're going. Because you know that's right, it's just not the correct format. What's the problem here? You can't have a square root in the bottom of a fraction. It's like you can't have 0 in the bottom. Can't have a root in the bottom, and I have completely run out of room. So I'm going to go over here. So we have this, right? 12 divided by square root 2. This is, in my calculator, 8.485, yada, yada, yada. Okay, so I'm just leaving that there so I know. Okay, so can't have a radical in the bottom. We need to get rid of it. But we we don't want to change the value of it, so recall from college algebra, we can multiply by that big old fat fancy 1, and now we can tweak the 1, right? Anything over itself is 1. So we're going to multiply by the issue. The issue is the root 2. So we multiply by root 2 over root 2 because that's a fancy 1. Remember to just multiply straight across. So you got 12 root 2 over square root 2 times square root 2 is square root 4, and the square root of 4 is 2. That's going to happen every time. You're going to come right back to that radicand with no square root, and that's by design. That was the whole purpose of doing this in the first place. So that happens every time. So that's kind of a shortcut. You know it's going to become a perfect square. And while that is still the correct answer, not simplified because this 2 will divide into that 12. Don't you dare shove it into that 2 there. That 2 is under a radical and this one's not, so those are not, you can't divide that into it. So the correct answer is 6 root 2. And then you would go to your calculator and you would type 6 square root 2, and you're going to see that it's the exact same decimal. Okay. The word for this is called rationalize. If I tell you you have the right answer but you need to rationalize, it means you need to go through this process. Okay? You've got to get rid of the square root in the bottom of the fraction. All right, so that's 45, 45, 90 triangles. The good news is 30, 60, 90 triangle is the exact same technique, different formulas. But there's nothing new. It's the same approach. You've got short problems, you've got longer problems that involve rationalizing, and they all stem from the formulas. Okay, so let's look at the formulas. 30, 60, 90. We've got one side that's plain x. We've got the hypotenuse that says 2 times x. And then we've got long side that says x times root 3. Okay? So you have 3 different formulas here. Here's the relationship between them all. This, change colors. You see how this is the 30-degree angle? Coming across from the 30-degree angle, it's going to create the short side. Okay, every time. Across from the 30 creates the short side. Across from the 60 creates the long side. And I don't have a lot of room there, so I'll write it here. And then, of course, across from the right angle is always the hypotenuse. I love the 30, 60, 90 problems because I've basically told there's only 3 scenarios, right? There's only 3 possible scenarios. Here, there's only 2 scenarios because the legs match. Here, there's 3 scenarios. If you're given the short side, listen, y'all know me, I come up with corny stuff. If you're given the short side, it's a short problem. You with me? If you know the short side, it's a short problem because if I know the short side is, say, 5, and then bam, the hypotenuse is 10, because you just double it. And then bam, the long side is 5 root 3. If you know the hypotenuse, you just cut it in half to come to the short side, and then you can state the long side. If you know the long side, it's a long problem. You with me? Long, not long, but longer, like going back to what we had to do right here. All right, so I'm going to say it again. I don't know if you want to write it somewhere. If you know the short side, it's a short problem. Maybe write it on a notebook paper or something. If you know the short side, it's a short problem. Which should then, and I don't know if you want to write this, but if you know the long side, then it's a long problem. They go hand in hand, okay? So that kind of also lets you know if you're on the right track. Like if you were given the short side and you're sitting there struggling with it, then you're not thinking it through because it should be a short problem. So the trick here is labeling the short, the long, and the hypotenuse before you attack the problem. So look at number 5. Y'all know me. I go to the right angle and I find the hypotenuse every time. Then I go to the 30-degree angle to find the short side. So there's the 30, which means coming across from it is the short, which makes this the long. All right, and then you go to what you know. I know the short, so it's a short problem. Shouldn't even need my calculator, really. So if the short side is 9, come over here, then the hypotenuse is double. So x would be 18. And then the long side is the short times root 3. So it would be 9 root 3. I know I went through that fast, but that's how fast the problem is. Did I lose anyone? All right, number 6 is an example of, well, let's label it. So we've got our hypotenuse here. Here's my 30, which makes this over here the short, and then this would be the long. Go to what you know. You know the hypotenuse is 24. If you know the hypotenuse, cut it in half to get the short. So the hypotenuse is 24. I'm going to make a note here, which means, I'm going to draw an arrow, which means the short is going to be what? 12. The short and the hypotenuse have a 1-to-2 ratio. And then now that I know the short, I can wrap up the problem with the long side. The long was y, so it's 12 root 3. Since number 8 also gives the hypotenuse, y'all jump to 8 and try it. And then we'll work 7. You already finished it? Y'all are going to love the practice assignment that goes with this. We're going to color.
Really?
Yeah. Coloring is actually therapeutic. Studies suggest coloring is a calming activity because it's brainless. You can calm your mind. Has everyone had a chance to answer 8? All right, so labeling it, this is the hypotenuse. That says 60. Coming across from it would make this the long, so that means this has to be the 30, and so this is the short. Okay, so go to what you know. Remember that phrase. I know the hypotenuse is 40. Well, if the hypotenuse is 40, then the short is 20. And if the short is 20, then the long is 20 square root 3. See, the difference here is if you get the Pythagorean theorem or a trig ratio, you're going to get a decimal. And with the unit circle, there are no decimals. We have radicals everywhere. And so that's why you've got to know these relationships and get familiar with the radicals so that when they start popping up in the unit circle, it's going to be a comfort zone. All right, 7. I'm just going to copy 7 to the other screen so that I'm not having to write super small and crowded and then it being hard for y'all to see. Paste. Okay, look at 7. Labeling it, we've got hypotenuse. Then this is 60, so this is the long side, and that would make this the short side, right? Okay, go to what you know. You know the long is 5 root 3, right? That's what I know. I'm just kind of making the notes myself. Then go to your formula sheet. Go to your formula sheet. What's the formula for the long? X root 3. And the x came from the short side, right? Okay, so short side root 3. So this right here has to be from the short side times root 3. See where this is going? So this long was me just stating what I know. If the short side times root 3 has to equal 5 root 3, then what's the short? It's 5. Do you see that? If you don't see that, you can set it equal. Right here, I have that the long is 5 root 3. What's the formula for the long? It's the short times root 3. Just bring this down. That's me replacing the formula. What do they have in common? They have root 3 in common. So what's the short? Which in this case is what letter? X. So the short is 5, which means X. See it? I want to show you another one that's not on there because there's another one that's not as pretty. But let's finish it. If the short's 5, what's the hypotenuse? What's the letter? Y. Y will be 10. Go to either the back of the notebook paper or if you have a little space. We are going to repeat that picture, but we're going to change this to say just the number 5. Because this does happen sometimes. Not a lot, but it will come up at some point. Somebody's going to say, you didn't show us how to do that one, and I want to make sure I do show you how because it is slightly different. Same technique, it's just because the number didn't end up canceling here, you have to rationalize. Luke, you with me? Okay. All right, so we're going to set it up just like before. This is the long side here. The long side comes from the formula short times root 3, right? What do I know? I know the long is 5. Okay, what's the formula for the long? It's short times root 3. And I'm going to set it equal to what I know. See, now the root 3's don't cancel. This is when it's not as pretty. You still go about it the same technique we did in that one where I had to open up a new tab. We're going to divide by root 3, so the short side is going to be 5 over root 3. And then you would finish this by, starts with an R, rationalizing it. In this case, my short side is the letter X, so you could put an X there if you wanted to. I need to rationalize this. What do I multiply by? Square root 3 over square root 3. And what do I get? Just shove it together. Right? Ugly. Start getting comfortable with ugly radicals or ugly fractions. Compartmentalize it. Think of it as 5 root 3 over 3. Now, if the short side is 5 root 3 over 3, then the hypotenuse is going to be double that, right? I'm going to say double short. I don't know why I wrote that out. I should have just done 2. 2 times the short. Hypotenuse is 2 times the short. We just found the short. How do you multiply that by 2? Be careful. I've seen people, red means wrong, take this and say times 2 is that. What's the wrong technique there? What did I do to get that? I multiplied the 2 and on the bottom and the top, which means I multiplied by 1. That's the problem. So when you take an ugly fraction and you multiply it times 2, I'm going to take this and double it. Think about it. Times 2 is understood to be over 1, so it's just the numerator you're doubling. So 5 root 3 doubled would be 10 root 3. Okay, so in this case, what's the hypotenuse letter? Y. It would be 10 root 3, still over 3. But you doubled the number on top. So be careful there. Problems like that don't come up a lot, but there will be one or a couple intermittent. And once again, if you know the long side, it's a long problem, and now you can see why. Now this one wasn't too long of a problem when it had the root 3 in it. But when it doesn't have the root 3, it does take more time. Okay? So, those are your notes on that. Here's your practice assignment, and I love it. I'm actually considering making it extra credit because I can't stand when I give coloring assignments to people and then they say, I don't want to color. And I'm like, okay, just trying to make things fun. And so I'm considering extra credit. You have to answer the questions. There's only 12. 12 questions. When you answer it, there's an answer key down here. Like, based on your answer, what number did you answer come to? And then it'll tell you what to color. And then this is what you colored. Okay? Yeah. Well, yeah, it's not due tomorrow. We'll say the coloring part's due Friday, or depending on. Got to glue it down. Okay, all right, I'll come get you.
And yes, I did. I just found.
Yeah, I remember when you were excited to do the thing last semester. Color. Luke, are you going to color? How about this? Hey, listen, because I do realize some people don't want to color.